union all. Return all the data, including duplicate data. Okay? You can test during the exercise lesson. The next one is nested query. So we already did this one using join operation. Retrieve the name and address of all employees who work for research department. But think about how we can access to such a data. First, we can access department, then find the research, then get the department number, right? Then compare with employee table, DNO. Can you understand? First, we are going to access the department whose name is research. Then get the D number. Then D number is the same as DNO in employee. That's the way. So let's do this query. This query has query inside the query. This is one query. Yes. And this is another query. First, why don't you take a look at the inside one. This is called inner query. Inner. This is outer query. Inner query will be executed first. So inner query select the D number. D number is a 5. Then DNO in means is just, we will see later, couple of slides later. In is the operation for set operation. So which means DNO in 1, 2, 3, something like that. Or one of these will be yes. Okay. So if you are not sure, let's change DNO is equal to this. Then this is a 5. Then from employee we are going to find employees whose DNO is a 5. That is first query inside, then return of the query will be used for outer query. That is called nested query. Query inside the query. So SQL allows such a query inside the query, inside the query, inside the query. That is because, that is the reason sometimes we have 2 pages, 3 pages long query. This is just one select, but it's very long. Okay, sometimes I have the longest one was the almost 5 pages. It's more than 200 lines of query. Okay, so you can make because of this nested query, query inside the query. Another query, the nested query is like this. Retrieve the name of each employee who has a dependent with the same first name as employee. See, in this case, this is the one query. Outer query, inner query. To execute the inner query, everything is fine except E. Actually, E is for in the outer query. So in this case, you need to access, this is called correlated nested query. What about the previous one? Previous one, they are independent. Directly can divide into 2. There is no relation. Output of this one can be used for inner query, outer query. However, in this query, you cannot cut half because there is E correlated. Okay? At that time, you need access one data for each employee. So then check inner query. Then next employee, then check this one. Okay? Also, you can use alias to represent the table in outer query. This is called the correlated nested query. Another example of this is, this is the same query as the last one, but sometimes you can use, it's not nested. It's not nested, it's based on join operation. Okay, using join operation, you can implement this. So it's depending on your application type. In terms of the output, it's the same. However, sometimes you'd better use the nested query. For example, this one. Depending on the input of user application, I can get this part. Or sometimes not. So at that time, you can use such a nested query. So you can implement the exactly same. You can get the exactly same output, which is based on the join operation. Can you remember this query? Retrieve the name of each employee who works on all the projects controlled by department number 5.
These are all the names of the employee who work on the department number 5.
You can implement this one in relational algebra with division. Can you remember division? So division is divide. For example, division. What is the project number controlled by department 5? For example, P1, P2. We try to find all employees who works for at least P1 and P2. It's a divide by P1 and P2. It's a division, but as I said, division is not popularly used in current DBMS system because it's a little bit hard to implement, also expensive. Instead, we can use this query. We're using contains. Contains means kind of set operation. The return of the first one should be larger than the next one. Contains. So this. So for example, let's see. P number 5 controlled by the department number 5 is, let's say, P1 and P2. Okay? Then select for each employee the PNO. So Social Security number 111 works for P1, P2, P3. Thus 111 will be returned. Is the 111 returned by this query? Yes, because it contains P1 and P2. So it's yes, true. So first name and last name will be returned. Okay? Then what about P1, P3, P4? No, it doesn't include P2. So 222 will not be returned. That is the contain. So you can use contain for such a nested query. Yes.
Contains. What does it mean? I didn't get please.
Simply, output of this one contains larger than this, which means, for example, P1, P2, P3. Output of this query is P1, P2. Which one is bigger? Thus, first query contains the next one. Yes or no? No?
Yes.
Yes. P1, P2 contains, include.
Okay.
And it's a yes. That employee will be returned.
So the first execution for the before contains.
No, before contain. Containing. You can execute this one separately.
No, I mean, but the logic of programming is like the first one and then the second one. Or the second.
It doesn't matter. It can be second and first one. Then check output. Whether first one include the second one. If yes, that SSN will be returned. There are more functions. For example, provided by the SQL. Another good one is this. Let's say this example. It's the same query between the name of each employee who has a dependent with the same first name as the employee. We use the nested query. So this is another nested query. Select dependent, where SSN is the same as ESSN, employees SSN. Okay, and first name is the same as the dependent name. If there exists such a dependent, we can return first name and last name. How can we check whether exists or not? Existing of nested query. At that time, we can use exist function. How many data? One or more. Okay, sometimes we can have more dependent who has the same first name. I'm not sure. But anyway, if one or more, at that time, we can check whether there exists. You don't have to make the count of dependent bigger than one. No, you don't have to do that. Just using exist. You can check the existence of the nested query, result of nested query. At the time, exists. What about the not exist? Which means zero, nothing. It's a not exist. So retrieve the name of employees who have no dependent. Check the dependent. No, nothing. It's not exist? Yes. That means return. Opposite of the exist. Existence of the nested query. Then in operation is like that. So in this case, retrieve the social security number of employees who was project number 1 or 2 or 3. So without using in, you can implement piano is equal to 1 or piano is equal to 2 or piano is equal to 3. We don't want such a duplicate data, right? So we can use in operation. One of this is in. What about null? The database relational model has a null constraint, not null constraint. What does the null mean? It doesn't exist, which means we cannot compare such a data. Then how can we check null or not? For example, I'd like to retrieve the name of all employees who do not have a supervisor. However, there is some. In other words, we can find the employee whose super SSN is null. Then we cannot compare null data, right? At that time, we can use null. Or is null. Is it null? Or is not null? So, super SN is null? Yes, then we return. This employee does not have social security supervisor.
Do we have it in the relational algebra?
Do we have
This operation in relational
Yes, you can use it. Actually, it's coming from the relational algebra. We do not cover all the things in relational algebra, so you can use such an operation in select condition, selection operation. Okay. Then next is a join operation. So in relational algebra, we have learned the different types of the join operation. Can you remember? Left outer join, right outer join, and full outer join. Left outer join means we have employee, we have the department. We try to retrieve all. So what is the normal join? We are going to return only matched one.
Inner join.
Not inner join, matched. First combine Cartesian product.
Yeah.
Then check the join condition, equijoin condition, right? That's the return data. If that join column is null, it will not be returned. Null, definitely not matched, right?
Yeah.
However, we want all the data, either null or matched or not matched. We want to keep all the data in left-hand side. Then right-hand side, matched one. If not matched, padding null. Okay, that is left outer join. Similarly, right outer join means I try to keep all the data on right-hand side. Then left, add matched one. If not matched, add null. We can test it during the exercise. Then, what about both sides? We can keep the both sides, then match and padding or padding null. This is the full outer join. Definitely SQL plus. SQL supports such a left outer join, right outer join, full outer join. For example, this is the left outer join. Employee, left outer join, and employees. So left hand side is E. Right hand side is the super SSN. And the
Employees is
is an employee. there is a space. Okay? So alias.
Alias.
It's an alias. So which means we try to keep all employees left hand side. Employee first name, employee last name, all employees. If there exists a supervisor, give first name and last name of the supervisor. Or if there is not existing the supervisor, add null label. Okay? So this is the left outer join. And or natural join. Okay. What is a natural join? As we have seen here, natural join with common column, same names of column. In this case, can you find any join condition? No, because it is natural join. So this is not frequently used. So don't worry about the natural join. So this is the project join with the department on join condition, and join employees on manager social security number is equal to SSN. This is the SQL standard. However, not frequently used. Not popular than the previous one. You'd better put the join condition to where condition. Okay? Then the next is the aggregate function. What is the aggregate function? Yes.
Functions that can work on a domain of attribute.
So aggregate function is the statistical data for each group. Okay? So for example, I'd like to find the maximum salary, minimum salary, and average salary of employee. Then from employee we can get the maximum salary, minimum salary, average salary. At this time, how many groups do you have?
Three.
Only one group.
Oh.
That group is employee. Then get the maximum data, minimum salary, or average salary. How many tuples will be returned? One data will be written because we have only one group. But in general, we have for each department. Retrieve the department number of employees in the department, and average salary. At that time, we have a grouping factor. It's grouped by DNO. Okay, then first group by department. First, you need to group employee by DNO. In this case, how many groups? We have 5 groups. 5 department, 1, 2, 3, 4, 5. Then compute the count and compute average salary for 1. Next, 2, 3. How many data will be returned? 5. It's the same as number. At this time, this is very important. Grouping factor must exist in select. Otherwise, if you omit this one, how do you know whose data is this? Right? So must use this group by factor should be the same as select without aggregate function. So DNO should be DNO. Okay? That's the first important thing when you are using group by factor. In this case, how many grouping factor? So we have 2. It should be grouped by P number as well as P name. That should be the same as in select. Then you can see which one is which. Okay? That is the most important one. Another thing is, in this case, why don't you forget about this condition? The 2 employees work. For each project, retrieve the project number, name, and number of employees who works on that project. So group by P number and P name. Without this, not a problem. Okay? Then P number and P name should exist on select clause. Then what if we had 2 employees work? At least 2 employees. So that is count should be bigger than 2. What if we add this one to where condition? This is a condition, right? What if we add this condition to where? Does it make sense?
No. Doesn't make sense.
See, 2 employees. First, we are going to find the project which has more than 2 employees. Which means, how can you compare it? First, you need to group by project. Then check whether this is more than 2, whether this is more than 2. So you cannot add such a condition, group condition for where. Instead, we have another having condition. Every final exam I ask exactly same question. Make the aggregate function. The accuracy is less than 10%. Okay? This is very important when you are using aggregate function. First, the grouping factor should be the same as this one on select. And also, if you have any condition for each group, it should not be in where? It should be outside of this. One more thing is, we do not have enough time for this. I'd like to spend a little bit time to explain that this doesn't take a time less than 5 minutes on Thursday. Okay? So on Thursday we are going to have another exercise lab on Tech 163. So please come to the 163, not this question. Okay? Thank you and see you next week.